Hello friends, welcome back. Tonight, I'm going to tell you about a wind that no longer exists, a cold so deep it could reshape bone over generations. I'm going to tell you about the Ice Age world, where our ancestors learned to survive, not despite the cold, but because of it. Where climate became an invisible sculptor, pressing against skin, metabolism and movement until the human body began to take the form we still carry today. This is the story of how the earth wrote itself into our flesh. They begin in constant environmental negotiation. Early Homo moved through landscapes where temperature swings violently across generations. A valley that supports life for decades can become uninhabitable within a single century. Forests retreat, then return. Rivers change course beneath sheets of ice. Entire animal populations vanish from familiar hunting grounds, replaced by unfamiliar herds, migrating under pressure from advancing cold. Survival is not a steady process. It is a repeated recalibration against a world that never settles. In these conditions, human bodies are not yet what they will become. They are flexible, experimental in their form. The earliest Homo species carry traits inherited from older ancestors, but those traits are constantly tested by climate. Long limbs that once helped dissipate heat in warmer African environments now become liabilities in colder latitudes. Lean physiques struggle to retain warmth during extended glacial winters. Now a generation that survives does so not because it is perfect, but because it is adaptable enough to endure another cycle of environmental uncertainty. The fossil record from these early periods is fragmented, but what survives tells a quiet story. Bones reveal subtle shifts in structure across time. Skull shapes gradually change, not in dramatic leaps, but in slow, accumulated adjustments. Teeth reflect diet transitions driven by scarcity and seasonal unpredictability. Even the thickness of bone begins to respond to new mechanical demands imposed by harsher terrain and heavier physical stress. No single moment defines these changes. Instead, they accumulate like sediment under pressure, forming the foundation of what will eventually become modern human anatomy. What makes this period especially significant is not just the cold itself, but the instability of the cold. Ice ages are not uniform freezes. They are rhythmic systems of advance and retreat. Glaciers expand, then partially collapse. Temperatures drop sharply, then rebound in brief deceptive warm phases. These oscillations force early humans into constant migration, pushing them to follow shifting animal herds and seasonal vegetation patterns across continents. Every move introduces new environmental pressures, and every pressure leaves traces in the body. Some groups begin to develop slightly shorter limbs, a subtle but important adjustment that reduces heat loss. Others show increased body mass, a biological response that helps conserve energy in long winters where food is unpredictable. Fat storage becomes not just a metabolic feature, but a survival strategy encoded into physiology. These are not conscious adaptations. They are outcomes of survival filtered through natural selection over countless generations of hardship. At the same time, cognitive flexibility becomes just as important as physical adaptation. Early humans, who can read changing landscapes more effectively, gain a critical advantage: the ability to track seasonal animal movements, remember distant water sources, and anticipate weather shifts begins to shape survival outcomes as much as physical endurance. The Ice Age world does not simply reward strength. It rewards perception, memory, and coordination within small, mobile groups. Archaeological evidence from this era, though sparse, reveals scattered signs of temporary camps rather than permanent settlements. These are not cities or villages, but brief interruptions in movement. Fire scars in ancient soil layers mark places where humans paused long enough to cook, to warm themselves, to survive another night, before continuing into uncertain terrain. Tools found at these sites are simple but highly functional, shaped for efficiency rather than permanence. Every object reflects a life lived on the edge of environmental pressure. What makes this early phase of human development so important to understanding modern appearance is the way climate acts as an invisible architect. There is no single force directing change. Instead, countless small pressures accumulate: cold winds, limited food sources, shifting landscapes, and unpredictable seasons. Over time, these pressures begin to sculpt not only behavior, but biology itself. The human body becomes a record of environmental negotiation. Yet, even in this frozen instability, something remarkable persists. Humans do not retreat into biological stagnation. They expand outward despite harsh conditions. Despite repeated climate shocks, early populations continue to spread across vast distances. This expansion ensures that no single environmental condition defines humanity. Instead, variation becomes the rule. Different groups encounter different climates, and those climates begin to write different versions of the human form. In the deep time of this Ice Age world, nothing about human appearance is fixed. Everything is in motion, shaped by forces far larger than any individual life. The cold is not just a backdrop. It is an active participant in human evolution, pressing against skin, bone, metabolism, and behavior. It is here, under shifting glaciers and unstable skies, that the first outlines of modern humanity are quietly drawn. And as these early populations continue to move through frozen landscapes that never fully settle, the story of human appearance begins not as a finished design, but as an ongoing response to a planet in constant climatic transformation. The Ice Age world does not simply press against human life. It rewrites it layer by layer, like a slow geological force working through flesh instead of stone. As glaciers expand and retreat across continents, the human body becomes a living archive of environmental negotiation. Nothing about its shape, color, or internal balance is accidental. Moe, this fear plate followed it into stiding to contistacy. Thinking the sometime, if the suit whenever distava a fuga sticknical monies, but, quote, fins for jutes over saved it, suit for semenatu, deplares so, glutti the chamber, the Cretan prevention, species, slaves to, deplares for to, belef with a spiritual religion. Think thing. Think thing. Thing. Think in colder environments the body faces a constant challenge preserving internal heat without exhausting energy reserves. Over generations, populations living in northern latitudes tend to develop broader torsos and shorter limbs, a pattern that reduces surface area relative to volume. This simple physical adjustment becomes a powerful survival advantage. Heat is retained more efficiently, and energy loss during long winters is reduced. In warmer regions, the opposite pattern emerges, with longer limbs helping to dissipate heat more effectively. These patterns are not planned. They are the result of survival outcomes repeated across thousands of generations. Individuals whose bodies are slightly better suited to their environment are more likely to survive, reproduce, and pass on those traits. Over time, these small differences accumulate into recognizable regional variations in human appearance. What begins as subtle variation eventually becomes visible structure. But temperature is only one part of the story. Light, especially ultraviolet radiation, becomes another invisible force shaping human evolution. Near the equator, intense sunlight carries both benefit and danger. It enables vitamin D production, essential for bone health, but it also risks damaging skin cells. In response, Populations in high UV environments tend to develop darker pigmentation, a protective adaptation that reduces the harmful effects of radiation while still allowing enough vitamin D synthesis for survival. In contrast, as human groups migrate into higher latitudes where sunlight becomes weaker and more seasonal, skin pigmentation gradually lightens. This is not a rapid transformation, but a slow adjustment across many generations. In these regions, the challenge is no longer blocking excess radiation, but capturing enough of it. Lighter skin allows more efficient vitamin D production in environments where sunlight is limited for long periods of the year. Then fossil and genetic records suggest that these changes occur independently in different regions at different times. There's no single moment when human skin changes color. Instead, there are overlapping waves of adaptation shaped by local climate conditions. What survives in the genetic record suggests a complex mosaic of human variation rather than a single uniform shift. Humidity and altitude also play important roles, though their effects are less immediately visible. In dry environments, respiratory efficiency becomes crucial. In high-altitude regions, oxygen scarcity forces physiological adaptation, including changes in blood composition and lung capacity. These adjustments can leave lasting marks on population structure, subtly influencing body development and even facial morphology over long periods of isolation. What makes climate so powerful in shaping human appearance is not any single factor, but their combination. Temperature, light, humidity, altitude, and seasonal instability interact in complex ways. A population does not adapt to one condition in isolation. It adapts to a full environmental system that constantly shifts and overlaps. This complexity explains why human variation is so diverse, even within relatively small geographic regions. Archaeological evidence reinforces this picture of gradual, regionally specific adaptation. Tools and habitation sites show repeated cycles of movement, abandonment, and return. Human groups are rarely stationary long enough for environmental pressure to stabilize into a single form. Instead, mobility becomes a defining feature of early human life. As groups move, they carry their biological adaptations with them, mixing traits across populations and creating further variation. There is also evidence that cultural behavior begins to influence biological outcomes indirectly. Clothing, fire use, shelter construction, and dietary flexibility all reduce direct environmental pressure on the body. In some regions, cultural adaptation slows biological change by buffering the harshest effects of climate. In others, where such buffering is limited, environmental forces act more directly on physiology. This interplay between culture and climate adds another layer of complexity. Human evolution is no longer purely biological. It becomes a feedback loop between environment, behavior, and physiology. A warmer shelter reduces cold stress, which in turn affects survival rates, which influences genetic transmission. Each layer modifies the others in subtle but cumulative ways. Yet, even with these protective behaviors, climate remains the dominant force shaping human form during this period. No tool or social structure fully removes its influence. Instead, humans exist in constant negotiation with environmental pressure, and their bodies reflect that negotiation in every structural detail. Across continents, from African savannas to Eurasian tundras, the same principle repeats. Climate does not simply influence human appearance, it defines the boundaries within which human variation is possible. Every trait from skin pigmentation to body proportion, from metabolic efficiency to skeletal density, carries traces of ancient environmental struggle. What emerges from this long process is not a single ideal human form, but a spectrum of forms, each tuned to the demands of a specific world. And beneath all of them lies the same underlying truth. The human body is not fixed. It is a record of survival, written by climate itself, revised endlessly across deep time. The first great movement of modern humans across the planet does not begin as a bold expansion, but as a slow drift driven by necessity. Climate shifts quietly rearrange the map of survival, and human groups follow the moving edge of habitability without ever seeing the full shape of what they're doing. Rivers freeze, and in new patterns. Grasslands expand into regions once locked beneath forest. Ice sheets advance, then pause, then retreat again, opening temporary corridors through which humans pass into unfamiliar worlds. These migrations are not singular events. They unfold in waves stretched across tens of thousands of years. Each wave carries small populations into new climates where the body is immediately tested by unfamiliar conditions. Heat patterns change, seasonal cycles differ, daylight duration shifts in ways that affect hunting, gathering, and even sleep cycles. Every new environment becomes a biological experiment that slowly filters human variation. As humans move out of Africa into Eurasia and beyond, they enter regions where climate becomes increasingly unstable. In some areas, extreme cold dominates for long periods, forcing adaptations in body structure and energy use. In others, monsoon systems create intense seasonal contrasts where abundance and scarcity alternate with dramatic force. These variations ensure that no single human population experiences climate in the same way for long enough to stabilize completely. Genetic evidence suggests that these migrations are not linear. They branch, overlap, and sometimes reverse. Groups that move into new territories may later retreat or merge with neighboring populations. This constant reshuffling creates a complex web of ancestry where human traits are shared, diluted, or reinforced depending on local conditions. Climate acts as the background force shaping all of these movements, but it never dictates a single path. One of the most significant consequences of this expansion is exposure to entirely new ecological systems. Think, and twist time. In Eurasia, humans encounter megafauna, adapted to cold environments, woolly mammoths, giant deer, and large predators shaped by Ice Age ecosystems. These animals are not just sources of food, they represent new survival pressures that influence hunting strategies, group coordination, and even physical endurance. The demands of tracking large migratory hordes across frozen terrain reinforce traits associated with stamina and resilience. At the same time, climate variability forces humans to become highly flexible in resource use. In stable environments, species can specialize. In unstable Ice Age landscapes, specialization becomes dangerous. Human survival depends on generalization, the ability to switch between hunting, gathering, fishing, and scavenging depending on seasonal availability. This flexibility reduces the likelihood of extinction during sudden environmental shifts. Archaeological sites from this period reveal a striking pattern of adaptation. Toolkits become more diverse as humans enter new regions. Stone tools are modified for different tasks, from butchering large animals to processing plant materials in environments where vegetation is highly seasonal. The variability in tool design reflects not cultural randomness, but environmental necessity. Climate diversity produces behavioral diversity, which in turn supports biological diversity. In colder regions, clothing becomes a critical innovation. While organic materials rarely survive in the archaeological record, indirect evidence suggests the use of animal hides and layered insulation. This cultural adaptation reduces direct environmental pressure on the body, allowing humans to survive in climates that would otherwise exceed physiological limits. Yet even with clothing, the underlying biological influence of cold remains present over generations. In warmer regions, particularly in tropical zones that remain stable compared to glacial landscapes, human populations experience different pressures. Here, disease ecology becomes a major factor. Warm, humid environments support higher pathogen loads influencing immune system evolution. Climate, in this sense, shapes not only external appearance, but internal biological systems, including disease resistance and metabolic regulation. One of the most important, but often overlooked aspects of these migrations is isolation. As populations move into new regions, some groups become geographically separated for thousands of years. Mountains, deserts, ice sheets, and oceans create barriers that limit interaction. In these isolated pockets, climate exerts a more concentrated influence. Without gene flow from other populations, local adaptations become more pronounced. Over time, these isolated groups develop distinct physical characteristics that reflect their specific environmental histories. Yet, even in isolation, occasional contact between populations reintroduces genetic diversity, blending traits shaped by different climates. The result is a constantly shifting mosaic of human appearance across the globe. There is also evidence that climate-driven migration influences social structure. Smaller groups in harsh environments tend to rely more heavily on cooperation and shared resource management. In such conditions, survival depends less on individual strength and more on collective coordination. This social adaptation indirectly shapes biological outcomes by increasing group stability and survival rates. What emerges from this long period of movement is a world in which humanity is never fully settled. Every generation exists in a state of transition, shaped by climates that are themselves in transition. Ice advances and retreats. Forests expand and collapse. Rivers carve new paths. Human populations follow these changes, carrying their evolving biology into every new environment they encounter. And through all of this movement, one pattern becomes increasingly clear. Human appearance is not a fixed inheritance from a single origin point. It is the product of repeated journeys through changing climates, each one leaving behind subtle marks on the body. Migration and climate are not separate forces in this story. They're deeply intertwined, shaping each other in ways that continue to define human diversity today. In the coldest reaches of the Ice Age world, where winter stretches across entire horizons and daylight feels like a brief hesitation in an otherwise endless night, the human body begins to take on a different logic. It is no longer shaped only by ancestry or chance. It is shaped by heat, or more precisely, by the absence of it. Every movement, every breath, every surviving generation carries the pressure of conserving energy and environments where even basic survival demands constant biological negotiation. The physical changes that emerge in these regions are not dramatic at first. They begin as subtle variations in body proportions, barely noticeable within a single lifetime. But across many generations, they accumulate into a consistent pattern. Populations living in colder climates tend to develop shorter limbs relative to body size. This is not a coincidence, but a thermodynamic response. A more compact body retains heat more efficiently, reducing the surface area through which warmth is lost to the environment. In contrast, populations in warmer climates often retain longer limbs, which help dissipate heat more effectively. This pattern, observed across both modern and ancient populations, reflects a principle that operates quietly beneath all human variation. The body is constantly balancing heat production and heat loss. In Ice Age environments where food is scarce and winters are long, energy efficiency becomes more important than speed or agility alone. A body that loses less heat requires less fuel to maintain core temperature, increasing the chance of survival during periods of scarcity. Fat storage also becomes a crucial adaptation. In colder regions, higher levels of subcutaneous fat provide both insulation and energy reserves. Is it not in Soman the Geibel, then we mean anything, now than know my conditioning with ne'er. I just becomes around the beer. Anything lives the direct division, and the opens just saying Macamia the and straight here. I want to go to my, I do that to live density slave. Think don't mean that is the slef is, contently, is the biasoon, the suppose for the vetral energy, the netta remestity the wensity biasoon, and the seagull late them to repaired in their respress as the merables, time atonement. Think, phone, atena tut sim that turnus libus sisa small is decel in the world of the lastus surfens holios, bone density hosel shifts in response to environmental stress. In harsh climates, where physical exertion is constant, walking through deep snow, carrying heavy loads of food, or constructing shelter, skeletal robustness becomes advantageous. The body adapts not only to temperature, but to the mechanical demands imposed by survival itself. Ninth, this usen pasta dull. The bosament ab the sween said sosum sans, saying sorcery is the pleasance search. Even muscle distribution begins to reflect these pressures, favoring strength and endurance over speed alone. Yet climate does not act in isolation. It interacts with behavior, and behavior modifies its effects. The use of fire becomes one of the most transformative human innovations in cold environments. Fire does not eliminate climate pressure, but it reduces its immediacy. It creates temporary pockets of stability where the body can recover from exposure. Around these fires, human groups extend their survival range deeper into colder territories than biology alone would allow. Shelter construction adds another layer of protection. The thinking. I've been think. Simple windbreaks evolve into more structured dwellings, often partially buried or reinforced with natural materials. These shelters reduce exposure to wind chill, one of the most dangerous aspects of cold environments. Even without changing the body directly, shelter modifies the selective pressures acting on human populations. By buffering the extremes of climate, clothing, too, plays a central role, while rarely preserved in the archaeological record. Indirect evidence suggests increasingly sophisticated use of animal hides sewn and layered for insulation. This cultural innovation reduces the direct biological impact of cold, allowing humans to survive in regions that would otherwise be uninhabitable. However, even with clothing, the underlying evolutionary pressures remain active over long periods, subtly influencing body form. One of the most important consequences of these adaptations is that they do not occur uniformly across all cold regions. Climate is not a single condition, but a spectrum. Some areas experience dry cold, where air is sharp and humidity low. Others experience wet cold, where dampness increases the risk of hypothermia. Each variation produces slightly different selective pressures, resulting in regional diversity, even within broadly similar climates. Archaeological findings from Ice Age Europe and parts of northern Asia show repeated cycles of occupation and abandonment, suggesting that human presence in these regions was never fully stable. Populations expand into cold zones during favorable periods, then retreat when conditions become too severe. This rhythm of expansion and contraction reinforces the importance of flexibility, both biological and cultural. In some cases, these cold-adapted populations remain isolated for thousands of years. Isolation intensifies the effects of climate-driven selection, allowing distinctive physical traits to become more pronounced. Yet, occasional contact with other groups reintroduces genetic variation, preventing complete divergence. The result is not separate human types, but a continuous gradient of adaptation shaped by overlapping environments. It is within this context that the modern understanding of human physical diversity begins to take shape. Skin tone, body proportions, and metabolic traits are not random differences. They are reflections of ancient environmental pressures, particularly those imposed by temperature and seasonal instability. Even today, traces of these Ice Age adaptations remain visible across global populations, embedded in anatomy that no longer faces the same extremes but still carries their memory. What makes this process especially complex is that it is never purely biological. Cultural practices, fire use, clothing, shelter, social cooperation constantly reshape the environment in which biological selection operates. In doing so, they blur the boundary between adaptation and invention. Human bodies evolve not only in response to climate itself, but in response to how humans choose to live within that climate. And so, in the frozen landscapes of the Ice Age, the human body becomes something more than a biological organism. It becomes a negotiated structure, shaped simultaneously by nature and by behavior, by external temperature and internal innovation. Every trait carries the imprint of survival under pressure, written slowly across generations that never experience stability. Only the constant demand to endure. High above, the equatorial belt where sunlight strikes the earth with relentless intensity, another kind of pressure begins to shape the human body. It is not cold that defines survival here, but light itself. Ultraviolet radiation, invisible yet powerful, becomes a constant biological force acting on skin, bone, and internal chemistry. In these regions, the human body is no longer adapting to preserve heat, but to regulate exposure to the sun. The earliest human populations living near the equator experienced this pressure continuously. Unlike temperate or polar regions, there is little seasonal relief. Day after day, year after year, sunlight arrives with similar strength, and the body must find ways to balance its benefits and dangers. On one hand, ultraviolet radiation is essential for vitamin D synthesis, a process critical for bone development and immune function. On the other hand, excessive exposure damages cellular structures, increasing long-term biological risk over thousands of generations. This tension produces one of the most visible patterns in human variation: skin pigmentation. In regions with intense ultraviolet exposure, darker skin pigmentation becomes more prevalent. Melanin, the biological pigment responsible for darker skin tones, acts as a natural protective barrier, reducing the penetration of harmful radiation, while still allowing sufficient light to support vitamin D production. This balance is delicate. Too much protection would lead to deficiency, and too little would increase cellular damage. In contrast, as human populations migrate into higher latitudes, where sunlight is weaker and more seasonal, the selective pressure shifts. Here, the challenge is not blocking ultraviolet radiation, but capturing enough of it. Lighter skin pigmentation becomes advantageous because it allows more efficient vitamin D synthesis in environments where sunlight is limited for long periods of the year. This shift does not occur quickly. It unfolds gradually across many generations as populations remain exposed to different levels of solar intensity. What's important to understand is that these changes are not linear or uniform. There is no single moment when skin color changes in a population. Instead, there are overlapping gradients shaped by migration, isolation, and environmental variation. Some groups remain in high UV environments for thousands of years, maintaining darker pigmentation. Others move repeatedly between regions, creating mixed adaptive pressures that produce a wide spectrum of variation. The fossil record offers limited direct evidence for pigmentation, but genetic studies provide a clearer picture. Variations in genes associated with melanin production show patterns that align closely with historical ultraviolet exposure levels. These patterns suggest repeated cycles of adaptation, migration, and reaptation, rather than a single evolutionary event. What survives in the record is not a simple map, but a complex mosaic shaped by shifting climates. UV radiation, however, is only part of the environmental equation. Heat stress also plays a critical role. In equatorial regions, where temperatures remain high throughout the year, the body must regulate internal temperature efficiently. Sweating becomes a key mechanism, allowing heat to dissipate through evaporation. Populations in these regions often show adaptations that enhance heat dissipation, including longer limbs and leaner body mass, which increase surface area relative to volume. This relationship between heat, light, and body form reinforces a broader principle. Human anatomy is deeply responsive to environmental energy flow. The body is not shaped in isolation, but in constant exchange with its surroundings. It absorbs energy, releases it, and adjusts its structure to maintain internal balance under external pressure. In some regions, particularly where equatorial climates intersect with dense forests, additional challenges arise. Limited airflow reduces the efficiency of heat dissipation, while high humidity slows evaporation. These conditions intensify thermal stress, creating even stronger selective pressures for physiological efficiency. Yet, cultural adaptations, such as clothing, shelter design, and activity patterns, often moderate these pressures, reducing their direct impact on biological evolution. There is also evidence that diet plays a role in how ultraviolet exposure influences human populations. In regions where fish or vitamin D-rich foods are abundant, the selective pressure on skin pigmentation may be reduced. This introduces another layer of complexity where environment and subsistence strategies interact in shaping physical traits. Climate does not act alone. It interacts with ecology, behavior, and resource availability in ways that are difficult to separate cleanly. As human populations expand outward from equatorial regions, they carry these adaptations with them, but in altered form. Migration introduces new environmental conditions that reshape existing traits. A population adapted to high UV exposure may find itself in low-light environments, where those same traits become less advantageous. Over time, natural selection adjusts these traits again, creating a dynamic balance that reflects movement across climatic zones. What emerges from this long process is a global distribution of human pigmentation that reflects ancient patterns of solar exposure. It is not a fixed system, but a living record of migration and adaptation. Each variation in skin tone carries traces of ancestral environments shaped by the intensity and duration of sunlight over thousands of years. Yet, even with this understanding, uncertainty remains. Scientists still debate the exact timing and sequence of pigmentation changes in different regions. The evidence is incomplete, and many details remain hidden in gaps between genetic data and archaeological context. Fit. Up. Ling then know. What is clear, however, is that ultraviolet radiation has been one of the most consistent environmental forces shaping human biology throughout prehistory. And so, beneath the shifting climates of ice ages and warm periods, beneath migrations across continents and oceans, a quieter story unfolds. It is the story of light itself, pressing against human skin, generation after generation, slowly sculpting one of the most visible aspects of human diversity. In this way, the sun becomes not just a source of life, but one of the oldest architects of human appearance. Long before deserts stretch across continents in their modern form, the Sahara is not a boundary of sand, but a living, shifting world of water, grass, and seasonal abundance. Leaks spread across basins that today hold nothing but heat and dust. Rivers cut through landscapes that now seem incapable of supporting even the simplest vegetation. Herds of animals move through open grasslands, following rains that arrive with irregular but life-giving rhythm. In this world, early human populations do not simply survive. They move through a landscape that repeatedly transforms its identity. But this transformation is never stable. The Sahara does not remain green. It does not remain desert. It oscillates between the two states over tens of thousands of years, driven by slow changes in Earth's orbital cycles and shifting monsoon systems. These climatic oscillations become one of the most powerful forces shaping human movement across Africa and beyond. Every time rainfall expands northward, humans follow. Every time drought returns, they retreat or disperse into more stable regions. This repeated expansion and contraction creates a unique evolutionary environment. Unlike regions with relatively stable climates, North Africa becomes a corridor of constant migration. Human groups move through it repeatedly, sometimes settling for generations before being forced to leave again. Each cycle leaves behind biological and cultural traces, but none remain permanent. Instead, the region functions as a dynamic bridge between populations, linking sub-Saharan Africa with the Mediterranean and the broader Eurasian world. Archaeological evidence from ancient lake beds and river systems buried beneath desert sands reveals a landscape once filled with human activity. Stone tools, remnants of settlements, and traces of fishing and hunting practices suggest that these green phases of the Sahara supported diverse and mobile populations. Yet, the same evidence also shows sudden abandonment. Sites that were once occupied become silent as climate shifts, leaving only faint marks of human presence beneath layers of sand. These environmental oscillations exert a powerful influence on human appearance, not through direct shaping, but through repeated cycles of population mixing and separation. When climates improve, groups that were previously isolated come into contact. When conditions worsen, they fragment again, dispersing into different ecological zones. This constant reshuffling prevents long-term isolation in many cases, creating a complex genetic landscape shaped by repeated interaction. At the same time, the Sahara acts as both a filter and a gateway. During dry phases, it becomes a barrier that restricts movement. During wet phases, it becomes a highway that connects distant regions. This dual nature ensures that human populations are never fully separated for long periods, but also never fully unified. Instead, they exist in a state of intermittent connection, shaped by climate cycles that operate on timescales far beyond individual lifespans. One of the most important consequences of this cyclical environment is the repeated migration out of Africa. As green corridors open, human populations move northward and eastward, entering new climatic zones. These movements are not singular events, but multiple waves spanning tens of thousands of years. Each wave carries genetic and cultural variation into new environments, where it interacts with local conditions and other migrating groups. In these new regions, human bodies encounter different selective pressures almost immediately. Cooler temperatures, seasonal food availability, and varying levels of sunlight begin to reshape physiology. But these changes are layered on top of existing adaptations developed in African environments. The result is not a replacement of traits, but a continuous modification of them. human appearance becomes a record of overlapping migrations through shifting climates. The Sahara's climatic cycles also influence technological development. In wetter periods, increased resource availability allows for more complex settlement patterns and tool production. In drier periods, mobility becomes essential, favoring portable technologies and flexible survival strategies. This alternation between stability and movement reinforces adaptability as a central feature of human evolution. There is also evidence that these environmental shifts influence social structures. During periods of abundance, larger groups can form, supported by predictable resources. During periods of scarcity, these groups fragment into smaller, more mobile units. This fluctuation affects not only survival strategies, but also the transmission of cultural knowledge, as traditions are carried across distances during migration and reshaped in new contexts. Yet, despite the richness of archaeological and climatic evidence, complexity of Sahara-driven migration remains difficult to reconstruct. Sediment layers are incomplete, ancient waterways are buried, genetic signals overlap across multiple migration waves. No single narrative fully captures the scale of these movements. What survives is a fragmented but consistent pattern. Climate change repeatedly opens and closes pathways that guide human dispersal. What makes the Sahara particularly significant in the story of human appearance is its role as a repeated meeting ground. Each time populations converge during wet phases, genetic exchange increases. Each time they separate during dry phases, local adaptation becomes more pronounced. This rhythm of connection and isolation helps explain the wide diversity of human traits observed today. Even in the present, traces of these ancient cycles remain embedded in human biology. Genetic markers point to repeated expansions and contractions of populations across North Africa. Physical traits reflect layers of adaptation accumulated through successive environmental phases. The desert may appear static now, but its history is one of constant transformation, and human evolution has unfolded within that rhythm. In the end, the Sahara is not simply a region of environmental change. It is a mechanism through which climate shapes human destiny, repeatedly opening and closing the pathways that connect populations across continents. And through every cycle of green abundance and desert expansion, the human body continues to record the story of movement, adaptation, and survival, written by the shifting edge of habitable Earth. At the edges of ancient coastlines, where rising and falling seas repeatedly redraw the map of the world, early humans encounter another kind of instability, one that moves not across land, but across time. Shorelines are never fixed. They advance inland during warm periods and retreat outward when ice expands across the planet. Entire coastal landscapes appear and disappear within the span of millennia, carrying with them traces of human life that are later erased by water and sediment. In warmer, interglacial phases, melting ice sheets release vast amounts of water into the oceans. Sea levels rise gradually, flooding low-lying plains that once supported rich ecosystems. Human groups living in these regions are forced to move inland or adapt to increasingly fragmented coastal environments. In colder periods, the process reverses. Sea levels drop, exposing new land ridges and shallow continental shelves that expand habitable territory. These cycles of flooding and exposure create a constantly shifting frontier between land and sea. Along these dynamic coastlines, early humans develop a close relationship with marine resources. Shellfish, fish, and coastal plants become important parts of the diet in many regions. This dietary shift has subtle but long-term biological consequences, influencing nutritional intake and, in some cases, affecting skeletal development and metabolic adaptation. Coastal living introduces a new dimension to human survival, one that is tied not only to land-based climate but also to oceanic systems. Archaeological evidence for these coastal populations is often difficult to recover because many of their settlements now lie submerged beneath modern seas. What survives is fragmentary shell, middens, stone tools, and occasional remnants of hearths preserved in ancient shoreline deposits. These scattered clues suggest that coastal environments supported sustained human activity for long periods, particularly during stable climatic phases. But stability is always temporary. As sea levels change, coastal populations are repeatedly displaced. Some move inland and integrate with interior groups, carrying coastal adaptations with them. Others follow the retreating shoreline, maintaining a maritime way of life as long as conditions allow. This constant movement contributes to genetic and cultural exchange between coastal and inland populations, adding another layer of complexity to human variation. One of the most important but least visible consequences of coastal living is mobility across water. Purely and simple watercraft, though rarely preserved in the archaeological record, would have allowed early humans to move between islands, coastal zones, and river systems. This mobility expands the range of interaction between populations, increasing genetic mixing and accelerating the spread of technologies and cultural practices. Climate plays a decisive role in shaping these coastal worlds. During warmer periods, increased rainfall and stable temperatures create rich estuarine environments that support dense ecosystems. During colder periods, harsh conditions reduce coastal productivity and force populations to rely on stored resources or migrate to more stable regions. This alternating pattern reinforces adaptability as a core survival strategy. Sea level change also influences the geography of migration. When oceans retreat during glacial periods, land bridges emerge, connecting regions that are otherwise separated by water. These temporary corridors allow human populations to expand into new territories, including previously inaccessible areas. When the seas return, these connections disappear again, isolating populations and allowing regional adaptations to develop independently. This cyclical connection and disconnection between landmasses creates a complex pattern of human dispersal. Populations are not simply expanding outward from a single point. They are moving through a world where geography itself is unstable, where coastlines shift, and where entire regions alternate between accessibility and isolation. Climate, in this sense, does not just shape environments, it reshapes the very pathways through which humans move. There is also evidence that coastal environments influence cognitive and social adaptation. The unpredictability of marine resources requires different strategies compared to inland hunting or gathering, timing tides, understanding seasonal fish migrations, and navigating coastal landscapes demand observation, memory, and coordination. These skills, developed over generations, contribute to the broader cognitive flexibility that characterizes modern humans. Yet despite their importance, coastal populations are among the most archaeologically elusive. Rising seas during interglacial periods have submerged many ancient settlements, erasing direct evidence of their existence. What remains is a patchwork of discoveries that hint at a much larger, now lost world of coastal human activity. In many cases, the full extent of this world may never be recovered. Still, indirect evidence suggests that coastal regions served as critical zones of interaction between different human populations. As sea levels fluctuated, these areas became meeting points where inland and maritime groups exchanged resources, tools, and genetic material. The fictions thinks this interaction contributes to the broader mosaic of human diversity, shaped not only by climate on land, but also by the rhythms of the ocean, What emerges from this long coastal history is a pattern of repeated transformation. Landscapes appear and disappear, populations move, adapt, and sometimes vanish beneath rising waters. And through it all, human biology continues to reflect the demands of a world where the boundary between land and sea is never fixed. In this sense, the ocean is not just a barrier or a resource. It is part of the same climatic system that shapes human appearance across the planet. Its rising and falling waters extend the influence of climate far beyond continental interiors, embedding environmental change into the very edges of human existence. And as these ancient coastlines continue to shift through deep time, they leave behind a quiet but powerful legacy, a record of human adaptation written not only on land, but beneath the sea itself. Deep within the rhythms of climate instability, there are moments when the Earth does not change gradually, but abruptly. Ice sheets collapse faster than expected. Ocean currents shift course. Volcanic eruptions inject sunlight-blocking particles into the atmosphere. Droughts arrive not as slow declines in rainfall, but as sudden failures of entire weather systems. In these moments, human populations are not shaped by slow adaptation, but by crisis. These abrupt climate events act like biological shockwaves. They do not simply influence where humans live, they determine how many survive. When food systems collapse across a region, populations shrink dramatically, not over centuries, but within generations. Archaeological layers from certain periods show sudden reductions in human activity, followed by long gaps before reoccupation. These gaps suggest that entire groups disappeared or were forced to relocate under extreme environmental stress. One of the most important consequences of these climate shocks is population bottlenecking. When only a small fraction of a population survives a catastrophic event, the genetic diversity of that group becomes permanently reduced. As these survivors repopulate new regions, their genetic traits become disproportionately influential in future generations. This is not because those traits are superior in a general sense, but because they are the ones that happen to survive a specific environmental crisis. Over time, these bottlenecks leave deep signatures in human genetics. Some traits become widespread not through gradual selection alone, but through survival accidents during extreme climate events. The human story, in this sense, is not only shaped by steady adaptation, but also by repeated narrowing and expansion of population size driven by environmental volatility. Ice Age climate fluctuations are particularly important in this process. Rapid warming and cooling cycles, sometimes occurring within a few generations, force repeated migrations and local extinctions. In some regions, entire ecosystems collapse and then reassemble in altered forms. Human groups caught in these transitions must either adapt quickly, move, or face disappearance. There is little time for gradual adjustment. Volcanic eruptions add another layer of unpredictability. Large eruptions can inject sulfur aerosols into the upper atmosphere, reducing global temperatures for several years. These volcanic winters disrupt growing seasons, collapse food supplies, and force human populations into survival mode. While the effects are temporary in geological terms, they are devastating in human terms. A few years of failed harvests can reshape entire populations. During such periods, the relationship between climate and human appearance becomes indirect but still powerful. It is not the eruption itself that changes physical traits, but the survival filters it creates. Groups with better access to diverse food sources, more flexible diets, or more effective social cooperation are more likely to survive. These survival differences influence which genetic traits persist into the next generation. Some researchers suggest that repeated climate shocks may have accelerated certain aspects of human adaptability. The need to survive frequent environmental instability could have favored traits related to behavioral flexibility, problem-solving, and social cohesion. While these traits are not directly visible in physical appearance, they influence population survival and therefore indirectly shape the biological profile of future generations. In the archaeological record, these crisis periods often appear as transitions. Tool traditions change rapidly. Settlement patterns become more mobile. Evidence of long-term habitation decreases in favor of short-term, highly adaptable camps. These shifts suggest that humans are reorganizing their survival strategies in response to environmental collapse rather than following gradual cultural evolution. What makes these abrupt events especially important in the broader story of human appearance is their ability to reset evolutionary trajectories. A population that was gradually adapting to one set of climatic conditions may suddenly be reduced in size, relocated, or mixed with other groups. This resets the balance of genetic variation and introduces new combinations of traits into future populations. Yet even in the aftermath of these crises, climate continues to act as the guiding force. Once populations stabilize again, slower patterns of adaptation resume, but they do so on a changed foundation, shaped by the unpredictable interruptions of earlier events. Human evolution becomes a layered process where gradual change is repeatedly interrupted by sudden environmental shocks. There is also a spatial dimension to these effects. Climate disasters rarely affect the entire planet equally. Some regions are more vulnerable than others depending on geography, altitude, and proximity to climatic systems like monsoons or ice sheets. As a result, some populations experience repeated bottlenecks, while others remain relatively stable. This uneven impact contributes further to global variation in human traits. Despite the dramatic nature of these events, they are not anomalies in Earth's history. They are part of its natural climatic variability. Over deep time, the planet cycles through phases of stability and instability, each leaving its imprint on living systems. Humans, as highly mobile and adaptable organisms, are uniquely shaped by this variability. And so, beneath the surface of calm evolutionary narratives lies a more turbulent reality. Human appearance is not only the product of steady environmental pressure, but also of sudden collapses, near extinctions, and recoveries. Each of these moments compresses history into a narrow window where survival determines future diversity. In this way, climate does not merely sculpt the human body slowly over time. It also periodically reshapes the entire human family tree in sharp, unexpected turns. And the echoes of those turns remain embedded in modern populations, visible in patterns of variation that trace back to ancient moments of environmental crisis across the northern hemisphere, where cold forest and steppe landscapes meet in shifting boundaries. The human story begins to overlap with other kinds of humanity. These are not yet the modern distinctions of culture or nation, but different branches of human evolution shaped by parallel climates. Neanderthals in the West, Denisovans in parts of Asia, and early Homo sapiens moving through overlapping territories all exist within the same climatic system, yet respond to it in different biological ways. The Ice Age world does not distribute these groups evenly. Instead, it separates them into ecological zones defined by temperature, altitude, and resource availability. Neanderthals, for example, are strongly associated with colder European environments, where short, powerful bodies and robust skeletal structures reflect long-term adaptation to intense glacial conditions. Denisovan-related populations appear in parts of Asia, where high altitude and variable climates impose different physiological demands. Early Homo sapiens, meanwhile, remain highly mobile, expanding into and across these regions with increasing reach over time. What is striking is not simply their coexistence, but their partial overlap. These groups are not fully isolated species in the modern sense. Genetic evidence shows that they occasionally interbreed when contact occurs at the edges of their territories. Climate plays a central role in these encounters. As ice sheets advance and retreat, habitats shift, forcing populations into new contact zones where previously separate groups meet. In these contact zones, biological exchange becomes possible. Small segments of DNA pass between populations, leaving lasting traces in modern human genomes. These genetic contributions are not uniform, but they reflect adaptation to local environments. Some inherited traits appear linked to immune responses, others to metabolism or environmental stress tolerance. In this way, climate-driven contact between human groups becomes a mechanism for transferring adaptive advantages across populations. Neanderthals, in particular, show a deep adaptation to cold and resource-scarce environments. Their robust build, large nasal cavities, and strong musculature reflect long-term survival in glacial Europe. These traits are not random. They represent a body shaped by repeated exposure to cold stress, seasonal scarcity, and physically demanding survival conditions. Yet despite this specialization, Neanderthal populations also show regional variation, suggesting that even they were not uniform. Denisovans remain less clearly defined in the archaeological record, but genetic evidence reveals their influence across parts of Asia and Oceania. Their adaptations may reflect a broader range of environments, including high-altitude regions where oxygen levels are low. This suggests that human diversity during this period is not limited to a simple cold versus warm division, but spans multiple environmental axes, including altitude, humidity, and seasonal variability. Homo sapiens, emerging from African populations shaped by intense sunlight and variable climates, carry a different adaptive profile. Their mobility, cognitive flexibility, and cultural adaptability allow them to enter and persist in environments already occupied by other human groups. Rather than being specialized for one climate, they appear increasingly generalized, capable of adjusting behaviorally to a wide range of conditions. Climate change during this period acts as a constant reshuffling mechanism. Ice sheets expand, pushing populations southward into glacial periods open corridors of movement, allowing expansion into previously inaccessible regions. These cycles repeatedly bring different human groups into proximity, increasing the likelihood of interaction, competition, and genetic exchange. Archaeological evidence of these interactions is indirect but persistent. Tool technologies show overlapping patterns of influence. Some Neanderthal sites contain tools that resemble those associated with early Homo sapiens, while some early Homo sapiens sites show techniques that may have originated in other human populations. These similarities suggest not only parallel development, but also occasional exchange of knowledge, likely facilitated by contact in shared landscapes. However, despite these interactions, each group retains distinct biological characteristics shaped by long-term climatic pressures. Climate does not erase difference, it defines it. Each population carries the imprint of the environments in which it evolved, even as contact introduces new variations into their genetic makeup. Over time, Homo sapiens begin to expand more widely across continents. This expansion is closely tied to their ability to adapt culturally rather than purely biologically. Fire use, clothing, complex social structures, and symbolic communication allow them to survive in environments that would otherwise require long-term biological specialization. This flexibility gives them an advantage in rapidly changing climates. As Homo sapiens spread, other human groups gradually disappear from the archaeological record. The reasons for this disappearance are complex and still debated. Climate change likely plays a role, altering habitats and resource availability. Competition between groups may also contribute. Genetic assimilation through interbreeding further blurs boundaries between populations. No single explanation fully accounts for the transitions observed in the record. What remains clear is that climate continues to shape the entire process. It determines where populations can survive, how they move, and when they come into contact. It influences not only biological adaptation, but also the opportunities for interaction between different human lineages. In the final overlap of these ancient groups, human evolution becomes less about separate branches and more about convergence under shared environmental pressure. Distinct populations shaped by different climates begin to merge into a more interconnected global lineage, yet the traces of their separate histories remain embedded in modern human biology. The Ice Age world, with all its shifting ice, unstable climates, and migrating populations, does not simply produce diversity. It also brings that diversity into contact, creating a complex web of ancestry that reflects both separation and connection. And within that web, climate remains the silent force guiding every encounter, every migration, and every transformation. Beneath the surface of Ice Age survival lies another pressure, less visible but just as decisive: the changing availability of food and the energy demands of the human brain. Engfählichen find in truth to understand the Kletlef Itmenen too. Think to people that demits the shift to the Camity physiology and the Crimtio Kates like a formatities who never gets quiet and the fallen seacher usuries eyeball up. I Lana's trial complete. If trite, use a 20% of proclator quote. But if you think a fullness cafferanty, you can be a diligent to visit many mexes. Babel is the secret X, who works out the testament underter of necrats. Less makerous and very on the good my taken, come to 484, vation point second, sin sinner in gena term. Dash obe, co sleep, country, said, co, 1. We different nant people dollar and teeth third. 8, 7, 15 ever 2 pretend stat for I, trandata gi mendana 1, 2, 8, 7 number 0, said at 27 as pass 1. O by daff, and dot quote clefan 7 2.100, exteen people dot mar, dot duffo Ivan 0 doesn't at stand at /0 hun 4 and o dash slav dot 847 dust 10.0 coton through in no etpal 7 dust 48 in data 4 dash 10 third dot does at 0 tun dot timothy left tezet dot fivend dot 0 root and dot 2 3 dot art 4 dot 0 dot fund dot. In environments where food is scarce or highly seasonal, survival favors efficiency and flexibility over constant high-energy expenditure. During periods of climatic instability in the Ice Age, food availability becomes unpredictable across vast regions. Herd migration shift with temperature changes. Plant growth cycles respond to rainfall patterns that vary dramatically from decade to decade. In such conditions, human populations must constantly adjust their diets, moving between hunting, gathering, scavenging, and in some regions, fishing. This dietary variability places strong selective pressure on metabolic flexibility. Evidence from archaeological sites suggests that early humans are not specialized feeders. Instead, they function as broad-spectrum foragers capable of exploiting whatever resources are available in a given season or region. This flexibility is not just behavioral. Over long periods, it influences physiology. Populations that can efficiently process diverse food sources are more likely to survive in unstable climates where specialization becomes a liability. Protein availability plays a particularly important role in brain development. In regions where animal protein is accessible, either through hunting or scavenging, energy-rich diets support neurological growth. In contrast, in environments where such resources are limited, populations rely more heavily on plant-based foods, requiring different metabolic adaptations. Climate indirectly controls these dietary patterns by shaping ecosystems and determining which resources are available at any given time. As humans expand into colder regions during glacial periods, they encounter ecosystems dominated by large herbivores adapted to steppe and tundra environments. These animals provide high-calorie food sources, but their availability is seasonal and unpredictable. Successful hunting of such species requires cooperation, planning, and knowledge of migration patterns. These cognitive demands reinforce neurological traits associated with memory, coordination, and long-term planning. In warmer regions, especially during interglacial periods, plant resources become more abundant and diverse. Fruits, roots, and seeds provide alternative energy sources, but they require detailed environmental knowledge to locate and harvest efficiently. Again, cognitive flexibility becomes a key survival trait. The brain is continuously shaped not only by raw energy intake, but by the complexity of decision-making required to access food. There is also evidence that cooking plays a transformative role in this evolutionary process. The use of fire to process food increases caloric efficiency by breaking down complex molecules, making nutrients easier to absorb. This innovation reduces the energy required for digestion and increases the net energy available to the body, including the brain. Over the time, this shift may have contributed to changes in human digestive anatomy, including reduced jaw size and smaller teeth compared to earlier ancestors. Dietary shifts also influence facial structure and skeletal development. Softer cooked foods reduce the mechanical stress placed on the jaw and skull during chewing. Over generations, this leads to more gracile facial features in many populations. However, these changes are not uniform and interact with other environmental pressures, including climate and resource availability. Fat metabolism becomes another important factor in colder environments. High-fat diets, often derived from animal sources, provide dense energy needed for survival in extreme conditions. Populations adapted to such diets may develop metabolic pathways that efficiently process fats, supporting both brain function and thermal regulation. In contrast, populations in warmer climates may rely more heavily on carbohydrates and plant-based energy sources, reflecting different ecological constraints. Climate-driven dietary variation also influences population health and resilience. Periods of environmental stress, such as prolonged droughts or cold phases, reduce food diversity and increased nutritional stress. These conditions can affect growth rates, immune function, and reproductive success. Over long periods, such pressures contribute to the shaping of population-level traits, including body size and developmental timing. One of the most important but often overlooked aspects of this process is the relationship between brain size and environmental complexity. In highly variable climates, where survival depends on adapting to rapidly changing conditions, cognitive flexibility becomes a strong selective advantage. The ability to remember seasonal patterns, anticipate environmental shifts, and coordinate group behavior enhances survival chances in ways that directly influence evolutionary outcomes. Yet this relationship is not straightforward. Larger brains require more energy, which is itself dependent on food availability. Climate, therefore, creates a tension between the benefits of increased cognitive capacity and the energetic costs required to sustain it. The Kalmali illusion navigates this tension through a combination of dietary flexibility, technological innovation, and social cooperation. What emerges from this long interaction between climate and nutrition is a deeply interconnected system. Food availability shapes brain development. Brain development shapes survival strategies. Survival strategies influence how humans interact with their environment, which, in turn, reshapes food availability through hunting, gathering, and ecological modification. In this way, the human brain is not simply a product of genetic evolution, it is also a product of climatic instability. Embedded within ecosystems that are constantly changing, every shift in temperature, rainfall, and vegetation leaves indirect marks on human cognition and physical form. And so, beneath the surface of Ice Age landscapes, another transformation unfolds quietly. While glaciers advance and retreat above the ground inside human populations, a different evolution is taking place. One where climate shapes not only how humans look, but how their minds are powered, sustained, and ultimately defined. There are moments in Earth's deep history when climate does not shift gradually, but collapses into sudden instability, as if the planet itself briefly loses its balance. Ice sheets fracture faster than they form, ocean currents weaken or reroute. Volcanic eruptions inject ash and sulfur into the atmosphere, dimming sunlight across entire continents. These events do not last forever, but in human terms, they reshape entire generations. Within this turbulence, human bodies and societies are forced to adapt under extreme and often unpredictable pressure. One of the most striking aspects of these abrupt climate disruptions is their speed. Unlike slow glacial cycles that unfold over millennia, these events can transform global temperatures within years or even decades. A volcanic winter, for example, can reduce average temperatures for multiple seasons, disrupting agriculture, migration, and food availability across vast regions. For early human populations, this is not an abstract environmental shift. It is immediate survival pressure. When crops fail or wild food sources collapse, human groups are forced into rapid behavioral change. They move earlier, travel farther, and consume a wider range of available resources. In some cases, entire regions become temporarily uninhabitable. Archaeological layers from certain periods show sudden abandonment of settlements followed by long gaps in human presence. These gaps suggest not gradual migration, but abrupt displacement triggered by environmental shock. Yet the effects of these events extend beyond immediate survival. They also influence long-term evolutionary trajectories through population bottlenecks. When a climate catastrophe reduces population size dramatically, only a fraction of genetic diversity survives. The traits carried by these survivors become disproportionately represented in future generations. This process does not favor better traits in a general sense, but rather those that happen to exist in the surviving group at the moment of crisis. Over time, repeated bottlenecks leave deep signatures in the human genome. Some traits become widespread not through slow adaptation alone, but through survival during environmental extremes. These moments act like filters, narrowing diversity and then allowing it to expand again as populations recover. The result is a layered genetic history shaped by cycles of contraction and expansion. Mark activity plays a particularly important role in this pattern. Large eruptions can inject sulfur aerosols into the upper atmosphere, reflecting sunlight and lowering global temperatures. The climatic effects can last several years, long enough to disrupt food systems and trigger migration on a large scale. In some cases, these eruptions coincide with other environmental stresses, amplifying their impact and increasing the severity of population decline. Ice core records and sediment layers suggest that such events are not rare in geological terms. They occur repeatedly across the span of human evolution, each leaving subtle but detectable marks in environmental and genetic data. While no single eruption defines human development, the cumulative effect of many such events contributes to the irregular rhythm of population change observed in prehistoric records. In these periods of crisis, human appearance is not directly altered by the events themselves, but by the selective pressures they create. Individuals with greater physiological resilience, more flexible diets, or stronger social cooperation networks are more likely to survive. These survival advantages, though context-dependent, influence which traits are passed into subsequent generations. Behavioral adaptation becomes especially important during these disruptions. Groups that can reorganize quickly, share resources effectively, and maintain cooperation under stress have higher survival rates. While behavior does not fossilize in the same way as bones, its effects are visible in settlement patterns, tool use, and migration routes. Rapid shifts in material culture often correspond to environmental instability, suggesting a strong link between climate shocks and social restructuring. There is also evidence that these abrupt climate events may have influenced the pace of cognitive and cultural evolution. In unstable environments, the ability to innovate quickly becomes a survival advantage. Tools must be adapted, routes must be recalculated, and food strategies must change. With limited warning, over long periods, this may have contributed to the development of increasingly flexible problem-solving abilities in human populations. However, it is important to distinguish between direct and indirect effects. Climate shocks do not create new human traits in a single generation. Instead, they reshape the conditions under which existing variation is filtered and expressed. The evolutionary impact is cumulative, emerging only after repeated cycles of disruption and recovery. Another key feature of these events is their uneven geographic impact. Some regions experience severe climate stress, while others remain relatively stable. This unevenness creates refugia areas, where populations can survive relatively intact while surrounding regions collapse. These refugia become critical reservoirs of genetic diversity, later repopulating affected areas once conditions stabilize. This pattern of collapse and refuge contributes to the patchwork structure of human genetic history. Rather than a single, continuous expansion, human populations repeatedly contract into safe zones and then expand outward again. Each cycle reshapes the distribution of traits across regions, blending the effects of climate, geography, and chance. Even in the aftermath of these disruptions, climate continues to exert influence. Recovery periods are not returns to a previous state, but transitions into new environmental configurations. Ice sheets may not reform in exactly the same way. Ocean currents may stabilize differently. Vegetation zones may shift permanently. Human populations adapt again, but now to a changed baseline. What emerges from this long sequence of instability is a deeper understanding of how fragile and interconnected human evolution truly is. The human body is not shaped by steady conditions alone, but by repeated interruptions, moments when the environment changes faster than biology can smoothly follow. And so, beneath the surface of apparent continuity in human appearance, there exists a hidden rhythm of disruption. Climate does not simply guide slow adaptation over time. It periodically compresses, reshapes, and redirects the entire trajectory of human diversity, leaving traces that remain visible long after the events themselves have faded into geological memory. Across the long arc of Ice Age time, there comes a point where human bodies begin to stabilize, not because climate becomes stable, but because survival strategies become sophisticated enough to buffer its extremes. This is the moment when the modern human body blueprint begins to emerge, not as a sudden invention, but as the result of countless overlapping pressures finally settling into a workable balance. Climate is still unstable, but humanity is now less exposed to its raw edges. By this stage, Homo sapiens populations have spread across nearly every major climatic zone on the planet, from Arctic tundra to equatorial forests, from arid steppe to coastal margins. Human groups now occupy environments that differ dramatically in temperature, humidity, sunlight, and seasonal variability. Yet, despite this diversity, the underlying structure of the human body begins to converge toward a recognizable pattern. This convergence is not uniform. It does not erase regional variation. Instead, it defines limits within which variation occurs. The human skeleton stabilizes into proportions that balance mobility and endurance. The skull retains a structure that supports a large brain while maintaining efficiency and energy use. 4. The digestive system reflects a flexible diet capable of processing both animal and plant-based resources. In each case, the body is not optimized for a single environment, but for adaptability across many. One of the key drivers of this stabilization is cultural buffering. Fire, clothing, shelter, and increasingly complex social organization reduced direct exposure to environmental extremes. In earlier phases of human evolution, climate acted directly on the body. Now much of that pressure is absorbed by behavior and technology. This does not remove climate from the equation. It changes the level at which it operates. Instead of shaping the body directly, climate increasingly shapes the conditions under which human societies operate. This shift has profound evolutionary consequences. Traits that once responded quickly to environmental stress now change more slowly. Biological adaptation does not disappear, but its tempo is altered. Cultural innovation accelerates faster than genetic change, creating a growing gap between environmental challenges and biological responses. Humans begin to adapt to climate, first through behavior, and only later, if at all, through physical change. Archaeological evidence from late Ice Age sites reflects this transition clearly. Settlement patterns become more stable in certain regions, with repeated occupation of favorable landscapes. Tools become more specialized, reflecting accumulated knowledge rather than immediate improvisation. Evidence of long-distance trade appears in some areas, suggesting increasing connectivity between groups living in different climates. This connectivity reduces isolation and increases genetic exchange, further stabilizing population-level traits. At the same time, climate continues to impose selective pressure, but in more indirect ways. Food scarcity during cold phases still favors metabolic efficiency. Seasonal variability still rewards cognitive flexibility. Sunlight differences still influence pigmentation patterns. But these pressures now interact with cultural systems that partially offset their effects. The result is a more complex evolutionary landscape, where biology and culture continuously shape one another. In colder regions, the combination of clothing, fire, and shelter allows humans to occupy environments that would previously have required stronger biological cold adaptations. Instead of evolving extreme physiological specialization, populations rely on technological insulation. This reduces the need for further drastic anatomical change. In warmer regions, similar buffering occurs through clothing practices, architectural innovation, and dietary diversity. Genetic studies suggest that by the end of the Ice Age, most major patterns of human physical diversity are already established. Seeing pigmentation gradients, Body proportion variations and metabolic differences are largely in place, reflecting earlier phases of intense climate-driven selection. What changes afterward is not the fundamental structure of human appearance, but its refinement and distribution through migration and intermixing. One of the most important consequences of this stabilization is increased global connectivity. As climates shift toward the end of the Ice Age, new migration routes open. Populations that were once separated by ice sheets, deserts, or dense forests begin to encounter one another more frequently. These encounters lead to genetic exchange, cultural diffusion, and further blending of previously distinct traits. However, even in this period of increasing connectivity, climate remains a background force. Rising temperatures at the end of the Ice Age trigger massive environmental restructuring. Glaciers retreat, sea levels rise, and ecosystems reorganize at large scales. Human populations must once again adapt. But now they do so from a more globally interconnected starting point. This later stage Ice Age world is not one of isolation, but of overlapping networks. Human groups are linked across vast distances by movement, exchange, and shared environmental pressures. Climate continues to shape where people can live, but it no longer defines them in isolation. Instead, it shapes a global system of variation, interaction, and adaptation. And so, the modern human body emerges not as a final product, but as a stabilized compromise between ancient environmental extremes and increasingly sophisticated cultural adaptation. It carries within it the memory of cold expansion, desert migration, coastal fluctuation, and volcanic disruption, all layered into a structure capable of surviving across nearly every environment on Earth. In this way, the Ice Age does not end human evolution. It sets its boundaries. It defines the range within which humanity will continue to change, even after the glaciers retreat and the planet enters a warmer, more familiar climate phase. When the Ice Age finally begins to loosen its grip on the planet, it does not do so evenly or gently. Glaciers retreat in uneven pulses, sometimes stabilizing for centuries before collapsing further inland. Meltwater reshapes entire landscapes, carving new rivers and flooding coastal plains that had been exposed for thousands of years. Forests return to regions long dominated by tundra, while deserts expand or contract in response to shifting rainfall patterns. The world does not simply warm, it reorganizes itself. For human populations, this transition marks a profound turning point. The environmental pressures that once forced constant adaptation begin to shift into new forms. Cold no longer defines survival in most regions. Instead, seasonality, resource distribution, and ecological complexity become the dominant forces shaping human life. The body that was shaped under Ice Age conditions now enters a different climatic framework, one that continues to influence appearance, but in more subtle and regionally varied ways. As temperatures rise, some of the physical traits that were advantageous in colder climates begin to lose their selective importance. In many regions, robust, cold-adapted body structures become less critical as insulation technologies and behavioral adaptations continue to buffer environmental extremes. However, these traits do not disappear. Evolution does not erase the past, and it layers new pressures over existing variation, gradually reshaping populations without fully resetting them. At the same time, expanding forests and rising sea levels force large-scale human migration. Coastal areas that once supported dense populations are submerged, while newly fertile inland regions attract movement. Rivers become migration corridors, guiding human expansion into previously unoccupied or sparsely populated zones. This redistribution of populations increases contact between groups that had been separated during colder phases. These new encounters accelerate genetic exchange. Traits that were once isolated within specific climatic regions begin to spread more widely. Skin pigmentation, body proportions, and metabolic adaptations become increasingly mixed across populations. This does not lead to uniformity, but to greater complexity. Human diversity becomes more fluid, shaped less by strict environmental boundaries and more by continuous interaction. In warmer post-Ice Age climates, dietary patterns also shift significantly. The retreat of glaciers opens new zones for plant growth, expanding the availability of edible resources. Agriculture begins to emerge independently in multiple regions, driven by the need to stabilize food supplies in environments that are now more seasonally predictable, but still vulnerable to fluctuation. The domestication of plants and animals introduces a new layer of environmental buffering that further reduces direct climatic pressure on human biology. This agricultural transition has deep consequences for human appearance and physiology. Diets become more carbohydrate-heavy in many regions, altering metabolic demands. Sedentary lifestyles begin to replace some of the highly mobile survival strategies of Ice Age populations. Over generations, these changes subtly influence skeletal structure, dental morphology, and overall body composition. Yet, these shifts are gradual and uneven, varying widely between regions and cultures. One of the most important developments in this period is the increasing separation between environment and direct biological adaptation. Instead of evolving primarily in response to climate, humans begin to reshape their environment to suit their needs. Irrigation systems, food storage, controlled burning, and early settlement planning reduce the immediate impact of climatic variability. Climate still matters, but its influence is mediated through human innovation. However, this does not mean that climate loses its evolutionary role. It continues to shape the boundaries within which human societies develop. Droughts, floods, and temperature fluctuations still influence migration, settlement stability, and population growth. In some regions, environmental instability remains severe enough to drive continued adaptation. In others, relative stability allows for rapid cultural and technological development. Archaeological evidence from early post-Ice Age settlements shows increasing complexity in social organization. Permanent or semi-permanent villages appear along with more specialized tool production and early forms of resource management. These developments suggest that humans are no longer purely responding to climate in an immediate survival sense, but are instead planning across longer time horizons, anticipating environmental variation rather than simply reacting to it. This shift has profound implications for human appearance, since environmental pressures become less directly lethal in many regions. The intensity of natural selection on certain physical traits begins to soften. However, regional differences persist due to lingering climatic variation and uneven access to resources. The result is a world where human diversity remains deeply connected to ancient environmental histories, but is increasingly shaped by cultural pathways. Even today, traces of this transitional period remain visible in human biology and distribution. Patterns of genetic variation still reflect the roots of post-Ice Age migration. Physical traits still align loosely with historical climatic zones. Even if modern life has significantly altered environmental exposure, the body carries memory not only of Ice Age extremes, but also of the warming world that followed. In this sense, the end of the Ice Age is not a conclusion, but a transformation in the relationship between humans and climate. The environment continues to matter, but its influence becomes more indirect, filtered through layers of cultural adaptation and technological control. Yet beneath these layers, the ancient patterns remain, still shaping the foundations of human variation. As the Earth enters a warmer and more stable climatic phase, humanity carries forward a body that is neither fully ancient nor fully modern, but a composite of both, shaped by ice, refined by warmth, and continuously adjusted by the long dialogue between environment and survival. In the long aftermath of the Ice Age, human populations enter a world that is warmer, more stable in some regions, yet far more complex in its environmental diversity. The retreat of glaciers has not simply revealed new land, it has reshaped entire climatic systems. Ocean currents adjust to new coastlines, monsoon patterns shift, and once frozen ecosystems give way to forests, grasslands, and expanding river networks. Humanity now lives in a world that is no longer defined by a single dominant force like glaciation, but by a mosaic of regional climates interacting in unpredictable ways. This new climatic reality accelerates human diversification in a different direction. Instead of being shaped primarily by extreme cold or uniform ice age pressures, populations now adapt to localized environments with sharper contrasts over shorter distances. A single region may contain fertile valleys, arid plateaus, dense forests, and coastal zones within relatively small geographic space. Each microenvironment introduces its own selective pressures, but these pressures are increasingly moderated by cultural adaptation. Agriculture becomes one of the most transformative forces in this period. As humans domesticate plants and animals, they begin to stabilize food production in ways that reduce direct dependence on wild environmental cycles. This shift does not eliminate climate's influence, but it changes its role. Instead of directly determining survival, climate now influences agricultural productivity, which in turn shapes population density, settlement patterns, and long-term health. In regions where agriculture thrives, human populations grow rapidly. Larger communities lead to increased genetic mixing, reducing the isolation that once intensified regional adaptation. In other areas where agriculture is less stable due to unpredictable rainfall or soil conditions, mobility remains important, preserving older patterns of movement and environmental responsiveness. This uneven development creates a world where human appearance is influenced as much by social and technological systems as by natural climate alone. One of the most significant consequences of this post-Ice Age transformation is the weakening of direct environmental selection on physical traits. Clothing, architecture, controlled fire, use, and later technological innovations increasingly buffer humans from temperature extremes, ultraviolet exposure, and seasonal scarcity. As a result, many traits that were once strongly shaped by climate begin to stabilize or change only gradually over long periods. However, this does not mean that biological evolution stops. Instead, it becomes more subtle, often acting through indirect pathways such as diet, disease exposure, and population structure. Dense agricultural settlements create new ecological conditions where infectious diseases spread more easily, introducing a different kind of selective pressure. Metabolic traits, immune responses, and even aspects of body composition begin to reflect these new environmental challenges. Migration remains a central force during this period, but its character changes. Instead of purely following animal herds or climatic corridors, human movement becomes increasingly shaped by resource availability, trade networks, and social organization. Rivers, coastlines, and fertile plains become long-term centers of settlement, while less hospitable regions are traversed, but less densely populated. As populations expand and interconnect, genetic exchange increases dramatically. Traits that were once confined to specific climatic regions begin to spread widely, blending across continents. This does not erase regional variation entirely, but it softens its boundaries. The human species becomes more interconnected, with biological diversity distributed across larger and more complex networks of interaction. Even so, the legacy of Ice Age climate remains deeply embedded. The broad patterns of human physical variation, skin pigmentation gradients, body proportions, and metabolic differences still reflect ancient environmental pressures. What changes in the post-Ice Age world is not the origin of these traits, but their distribution and interaction within increasingly connected populations. There is also a psychological and cultural dimension to this transformation. As humans gain greater control over their environments, their relationship with climate becomes less immediate, but not less important. Weather no longer determines survival on a daily basis in many regions, yet long-term climatic shifts still shape agricultural cycles, for settlement stability and societal development. Climate becomes something that is observed, managed, and sometimes feared rather than directly endured. Archaeological evidence from early agricultural societies shows increasing complexity in social structures with specialized labor, long-distance trade, and emerging governance systems. These developments create new forms of environmental buffering, further reducing direct selection pressure on physical traits. Yet they also introduce new forms of inequality and regional vulnerability, particularly in response to droughts, floods, and long-term climate fluctuations. What emerges from this post-Ice Age world is a layered system of human adaptation. At the deepest level lie ancient biological responses shaped by Ice Age climates. Above that lies a layer of agricultural and sedentary adaptation shaped by more stable but still variable environments. Above that increasingly lies cultural and technological adaptation, which now plays a dominant role in mediating the relationship between humans and climate. This layered structure means that human appearance today is not the product of a single environmental epoch, but of multiple overlapping climatic eras. Ice Age pressures, post-Ice Age warming, think. Regional agricultural development, and ongoing environmental variability all contribute to the diversity seen in modern human populations. And yet, despite all this complexity, one underlying pattern remains consistent. Human biology continues to reflect the environments in which populations once lived, even when those environments no longer exist in the same form. The body becomes a historical record, preserving traces of ancient climates beneath layers of cultural and technological change. As the post-Ice Age world continues to evolve, humanity moves further into a phase where climate no longer acts as a single shaping force, but as one influence among many. Yet its legacy remains everywhere, written into the structure of human diversity, waiting to be read across time. In the present form of humanity, climate no longer appears as the dominant sculptor of daily survival, yet its deepest influence has never truly disappeared. It has simply moved into the background, operating through layers of history, biology, and culture that now separate modern humans from the raw environmental pressures that once defined existence. The body that walks across cities, farms, and digital landscape still carries within it the imprint of ancient worlds, shaped by ice, sun, drought, and shifting seas. Modern human appearance is often assumed to be a product of recent history, shaped by agriculture, civilization, and technological progress. But beneath these relatively recent developments lies a far older structure. Skin pigmentation patterns still reflect ancient variations in ultraviolet exposure. Body proportions still echo long-forgotten adaptations to heat and cold. Metabolic differences still carry traces of environments where food was scarce, seasonal, or unpredictable. These traits do not belong to the present moment alone. They are echoes of deep time, preserved through countless generations. What makes this legacy particularly complex is that human evolution has never been reset by any single environmental transition. The end of the Ice Age did not erase its effects. The rise of agriculture did not replace earlier adaptations. Instead, each new phase of human history has layered itself over the previous one. The result is a biological structure that resembles a palimpsest where older inscriptions remain visible beneath newer writing. Climate in this layered system continues to influence humanity indirectly. It shapes agriculture, which shapes settlement patterns, which shape population density, which shapes disease environments, which in turn influence biological traits. Even in a world dominated by technology, climate remains embedded in the foundations of human life. It is no longer always visible, but it is never absent. One of the most important realizations from modern anthropology and genetics is that human diversity cannot be understood without considering these long climatic histories. Populations do not differ in appearance because of a single environmental factor, but because of multiple overlapping histories of adaptations. Some traits reflect ancient desert environments. Others reflect Ice Age cold. Others still reflect coastal living, high-altitude survival, or agricultural transitions. Each layer contributes to the complexity of the whole. At the same time, modern globalization has begun to reshape the distribution of this diversity. Migration, urbanization, and intercontinental connectivity are increasing the rate of genetic mixing on a scale never seen before in human history. This does not erase ancient adaptations, but it redistributes them, blending traits that were once regionally concentrated. The result is a population structure that is increasingly interconnected, yet still deeply rooted in ancient environmental divergence. Even as this blending continues, climate change in the modern era introduces a new and uncertain chapter. Unlike the slow orbital cycles of the Ice Age, current climatic shifts are rapid and influenced by both natural and human factors. Rising temperatures, shifting rainfall patterns, and increased environmental instability are beginning to reintroduce selective pressures in ways that are still unfolding. The long-term biological consequences of these changes remain unknown, but they will inevitably interact with the deep historical layers already embedded in human populations. What remains constant throughout all of this is the fundamental relationship between humans and environment. Whether in Ice Age tundra, Green Sahara corridors, coastal plains now submerged, or modern cities, human bodies and societies have always been shaped in response to the conditions around them. The form that humanity takes is never fixed. It is continuously negotiated between biology, behavior, and the Earth itself. Looking back across this vast timeline from the earliest Ice Age adaptations to the present day, what emerges is not a simple story of progress or change, but a continuous dialogue. Climate speaks through pressure, scarcity, abundance, and instability. Humanity responds through migration, adaptation, innovation, and survival. Each generation inherits not only genes, but the accumulated memory of environments it no longer directly experiences. In the end, the mystery of how climate changed human appearance is not about a single cause or moment. It is about a long, unfinished relationship between a living planet and a species capable of moving across it. Every feature of the human body carries traces of that relationship, written across deep time in patterns that are still being interpreted, still being discovered, and still being shaped by the world that continues to change around us. And perhaps the most profound realization is this: human appearance is not simply a reflection of where we are now, but a record of everywhere we have ever been. Thank you for being here. If you enjoyed this, please like and subscribe. It means the world to know that someone out there is listening. Good night.